Multivariable optimization. Now, how do we calculate first order conditions and check whether the extreme points which are generated by first order conditions are indeed maxima or minima in case if you have a multiple variable function? So for example, this function, now this is in terms of x and y, as you could see. So this z is the function of x and y. This can't be written entirely in terms of x or entirely in terms of y. Now, how do we calculate the optimal points for this kind of a function? Since this is in terms of x and y, so what will you do is that you will try to calculate two partial derivatives in this case, one with respect to x, other with respect to y, since this is in terms of x and y, and you will put this equal to 0, and these two partial derivatives, when they are set equal to 0, they will generate two equations, and hence there will be 2 points for x and y. So just see this, that del z by del x in this case will give you 2x minus y plus 3 equals to 0, and del z by del y will give you minus x plus 2y equals to 0. Now when these two equations they are set equals to 0, so from the second equation what you have is x is equal to 2y. This is what you get from the second equation. Now if you substitute this x into y, what will you get is, in place of x you can write 2y minus y plus 3 equal to 0. This will give you 4y minus y plus 3 equal to 0, which will fetch you 3y plus 3 equal to 0, which will give you y equal to minus 1. Okay, now in case if y is equal to minus 1, you can substitute it back into x equals to 2y. So x would be equal to 2 into minus 1, which is x equals to minus 2. Well, you can check this substituting it in any of these equations. Well, you should be checking it in both equations, but I'll check this for only one equation for you, which is minus of minus 2 plus 2 into minus 1 will give you what? This is 2 minus 2 equal to 0. Hence these 2 points, they are satisfying these two equations. You should be checking this for this first equation also. So the two critical points which you have got are x equals to minus 2 and y equal to minus 1. Note that we are doing unconstrained optimization. There is no constraint right now. You are just given a function and you have to find out the optimal points for that.